down. Let's bring it together. So today is 6.11, 6.12, exploring circles. So with circles, today specifically, we're going to be looking at the circles and then also the angles that are involved inside. Some things are going to be really straightforward and simple. There's only like 2 parts of this that are a little tricky. So let's just start with what we know already. First off, when I have 2 angles, and let's say that this is 60 degrees, what is the other angle across from it? 60 degrees. So we think about the examples with, scissors or any kind of angles. If I'm opening up the top angle here, the bottom is opening the same amount. You see that? The top and bottom open the same amount, the sides open the same amount. So vertical angles, we know, are congruent. So right here I would say, oh yeah, hey, that's 60 as well. That's the basic right here. We have to remember vertical angles are, what's the word for it? When they're the same. Congruent. So they're the same, they're congruent. Okay? So we just got to recall that. Part of what we do today is involved thinking about that a little bit. Next, we have certain parts of the circle. We know that the center is in the center. The radius is from the center to the outside, and that's going to be the same all the way around. Okay. We also know that a chord is cutting the circle between 2 points on the edges of the circle here. That's just like a chord. And I kind of think of it like this. The way I remember chord is I think of, oh man. That's okay. Guitar, right? Yeah. Here's the hole of the guitar. I think of guitar because I play guitar, so I think about this stuff. But these strings go across, it's ukulele actually. The strings go across the hole, right? And when you play guitar, what can you do? You can strike a what? Strike a chord, right? So I think of this, if this is my circle right here, then my chord is just any line that starts on the edges of the circle and splits that circle with one little segment there. Okay, so strike a chord. Chords are just basically these little segments around the edges of the circle. Boom, it could be anywhere. It could be anywhere. It could even be a very specific one where, just like in the warm-up, a chord can also be the diameter, which is just 2 of these two radii combined together. Okay, so I know some of this stuff is a little review. Some of it is going to be a little bit dry as we go through it, but the same thing is going to apply every single time. However the sides or the angles interact from these rules, we can apply that to either numbers or expressions. We can do the same thing we've been doing the last few weeks. Okay, so looking here, first off, if I have a central angle which goes to the center, central angle to the center, then this minor arc and major arc are defined by these outer portions. So you can just imagine that, you're going to invite a bunch of friends over, so you buy a pizza, but there's there's like a hail and rainstorm going on, so everyone arrives really late, and you got hungry. It's not your fault, right? You got hungry, and here's the center. You decided, well, I need to make sure I'm not going to famish here, so.
Plus, you bought the pizza, so they can't pitch in.
They didn't pitch in, right? So, guess how much I ate? I ate all that. And this isn't to scale. If it was to scale, it would be like this. It's one of those super Costco pizzas. So it has, 18-inch slices, no big deal, you've seen that. So if I ate all this much, did I eat the major arc or the minor arc? And tell me why. So actually talk with your neighbor for 5 seconds. Which is the major and the minor arc? All right.
Yeah, let's go home.
Oh my gosh.
Okay. 3, 2, 1. All right. You ate this part. Did you eat the major or the minor arc? Minor. How do you know? Who could tell me that?
Because it's less than 50% of the circle.
Good, good. So it's a smaller portion. Good. So if you ate all this part, you ate the minor arc. How much did you leave over for your friends?
The majority.
Not too much, but yeah, the majority, but you're bringing over 10 friends, so guess what? They're not going to be happy. Barely. All right, you have a minor arc, you have a major arc. All right? You have the central angle, which is this central angle right here, goes to the center. So we just learned this. Actually, we didn't yet. But this degree from the central angle, it's a perfect match. Whatever the central angle is, that arc that it creates is going to have the same measurement. We're talking about degrees. So the degrees of the angle is equal to the degrees covered by this arc. So all the way around is how many degrees? All the way around a circle? All the way around? 360. Write that down, actually. Let's go and write that down if you questioned that or you weren't sure. So a circle is 360 degrees. So what I could say here is, if this is 60 degrees, then my measure of AC, if this is 60, the measure of AC is 60. So go and fill that in right here. If the measure B is 60, then I know my arc AC is also 60. Also notice here, you see this little kind of a little bow right here. Instead of a straight line, which would be a segment, this is just the arc. Okay, that's the arc AC. That's why we put that little arc symbol to remind us. All right. So again, there's going to be two kinds of problems. There's going to be central angles, which just match the outer arc and the central angle. They're the same. And then we have this other option is inscribed angles. So that's the only other option we have here. All right. So first off, let me go ahead and erase this stuff. All right. So let's go ahead and draw a perfect circle. Almost. All right. Here's the center. Let's say that this angle right here, this angle between the points, this angle, let's say that that is 30 degrees. 30 degrees. Then what is the... Whatever. All right, if that's 30 degrees, then what is the outside arc length going to be for that same angle? The central angle is 30. What's that arc measurement? 30. We learned that over here. Remember that if the central angle is 60, then that outer arc is 60 degrees. Degrees. So here's the deal, though. Now we have a different kind of angle. It's called the inscribed angle. Instead of our central angle, this inscribed angle starts at the other side of the circle. It goes all the way across. So here's the deal. We already figured out that this was how much? 30 degrees. Okay. Watch what's going to happen. I'm going to take this piece of the pie, which fit right here, right? Watch what I'm going to do. What am I doing? Fold it in half, right? What do you think is going to happen with this fold in half? Is there something that I'm trying to do? What do you think I'm trying to teach you?
The inscribed angle or whatever.
Good.
Angle on the outside.
There it is. Watch. I fold it in half. How's that look?
Good.
Looks pretty good, right? It's not drawn perfectly. But what did we just learn? We learned that if my central angle is 30, that tells me that the arc measurement is 30 degrees. I take that 30, I fold it in half. What's this measurement? 15 fits perfectly right here. So we can say that the inscribed angle is half as big as that opposite arc angle. You agree with that?
Yeah.
See, I folded it in half, so it's just twice, or half as big. So again, this is where we come into, what are these problems going to look like? What is this going to look like anyway? So let's say that I know this is 30. And let's say that I know that this is 2x plus 10. Just like last week, just like the week before, just like the week before. What are we going to do with those two expressions? So expression actually here is 2x plus 10, and then I have a value for 30 degrees. How much bigger is this angle than our inscribed angle? Right? So if this is my inscribed angle, how big is the opposite arc? It's twice as big. You agree? So here's this. I know that my inscribed angle is half as big, so I know that that opposite arc is twice as big. So watch. Here's the inscribed. Ugh. The inscribed angle is 2x plus 10, and what I know is if I have two of those inscribed angles, I equal the arc. Okay. This is twice as big, so I have to double the inscribed angle. Now watch what happens. 4x plus 20 is equal to 30. 4x is equal to 10. X is equal to 10 over 4. X is equal to 2.5. Just like before. All we... Yeah.
No, yeah, I was okay because this is funny.
Oh, you have the legislative to see?
Yeah.
Okay. So if I know this is 30, I know right off the bat this is 15 degrees. So you could have also said 2x plus 10 is equal to 15. That would have worked too. Yeah, Allie? Yes. Okay. All right, how do we feel about this one? It's a little different than central angle, but it's just twice as big, right? When something's twice as big, hopefully it makes it easy. Easy to remember. All right, let's look at the next thing. Okay, we're going to use the same exact idea because this next bit is still about inscribed angles. Now I want you to look at this. This is 30, right? So what is this measurement right here? This is 30, so this is 15. Everybody positive with that. Remember, the inscribed angle is half as big as that opposite arc. So now watch this. I want you to look at this and think about it the same way that we were looking at. This 30 between these 2 points tells me my inscribed is 15. Now what about this one? What about this one? Now for the orange angle here, right? The orange angle still has this arc of 30 degrees, so what is the measurement of this orange angle? You get it?
Yes.
If that opposite arc is the same length, then that inscribed angle has to be the same. All right, we'll do one more like this, and I think we'll be good with this one. So what if we have an angle right here? It's inscribed. It meets an arc that is 30 degrees, so what is this angle right here? How much? I hear some people not sure. But we'll start again. The black angle had 30, so I know the inscribed is 15. The orange angle had 30 for the arc. I know the inscribed angle is 15. This one has 30 for the arc, so my inscribed angle? 15. See how it's going to work every time? Okay. Easy, right? So we would just relate the angles in the same way. So if I knew that this one was 15, but this one is 5x, how could I find x? What are we going to do with that? Nadia? Plug what? So you found x.
Oh, never mind. Multiple by 3.
Okay, so you found the answer. How did you figure that out?
Oh, you can do 5x equals 30, and then divide on it. You know it has to be half of it.
That's correct.
So you do 30 divided by 2.
Okay. So you're saying we could set up like this? I like that you came to that conclusion because also I know that this is 15 because of the opposite arc. I know this is 15 because of the opposite arc. I know this is 15 because of the opposite arc. That's why we can make the logic that this must be 15 because all of them are. So I make the 5x equal to 15. What was the other way to do it?
Well, I have the question. Like, on the test, are you gonna like have this? If that's a problem, are you gonna have this like? Do you want to show the work, or do you want to go with logic and just show?
Oh, yeah, absolutely. Always show your work. Yeah, yeah, show me. Show me. It's not so much. It's not so much. I'm sure there's a lot of notes and writing you have to do in other classes too.
All fun.
All fine, huh? That's good. All right, so that's just 3. Done those. All right, so that was showing that angle A and angle D are going to be congruent to each other because of that opposite arc. The inscribed angle has the intersection of the circle at the same points. So just like this one, we know that they're the same. Okay, last little bit. Last bit. Now with this one, we have, ooh, nice. We have 2, what are these called again? Remember the guitar? What do we call it? Chord. So these are 2 chords. They're exactly the same too. They're exactly the same. Now if I have, let's see, I want you to think about it like this. You know, you're getting ready for your friends to come over, and you're like, well, I'm going to cut out this piece of pizza and this piece of pizza. Because that's just how you do things. Because they have the best pieces right here. They have the best pieces of pepperoni. You're like, I want the best one. Other parts are kind of burnt. You're like, that's for my friends. So let's not. If I cut this piece of pizza, now the thing that I know it's the same. What tick marks up here show me that something is the same? What tick marks show me that something's the same? Out here, right? These chords are exactly the same length because those tick marks. And side note, we also know that these are all radii. They're all the same length because they're all radius. Right? But if I'm just looking at this, if you cut a piece of pizza, now imagine cutting a piece of pizza, if you're cutting that same length of a chord, what do you know about those angles? What do you think about those angles? They're the same, good. So I know that this angle is the same as this angle because as I am thinking about how much I want to eat, I want to eat a lot. So these are too big. I can do it. I can do it. All right. So as I'm deciding how much to cut, watch what happens with the chord. I'm spacing over the chord, and now I've done all the chord, right? Over here, if I open it the same exact amount, that's a horrible use of rulers. I open it the exact same measurement to get that same length of the chords. So looking at that, again, if you just remember this from definitions, if this is 40, 48, then that's 48 because it's a central angle. If this is 48, what's this? 48. So again, this is how we're going to approach these problems. If I had this situation and I didn't know this was 48, but I knew that it was 3x plus 3. What can I do with those 2 angles? With this one and this one? Almost. Thank you. Because we know that they have the same length of these chords, that tells me that the angle must have opened the same exact amount. So these are congruent. So we do 48 is equal to 3x plus 3. Again, every single time when we're doing anything with geometry for the rest of the year here, anytime I have 2 parts that are congruent, then the values or expressions in those 2 parts are also the same. So I come to this point, I subtract 3, 45 is equal to 3x, and then I'm just going to solve for x, 15. Okay. This one's the hardest one, but basically just remember, chords are the same, then the central angles have to be the same, and those arcs have to be the same. Okay, so just to recap, we have central angle kind of problems. That has a perfect match. We have inscribed angles, which are the arc measurement is twice as big as the inscribed. And then we apply some of those ideas here. and the last one, they're central angles. So we have central angles and we have inscribed angles. Those are the two different parts, okay? All right, thumbs up, sideways down for this so far? All right, all good. So we don't have the workbooks yet, so everything is on the iMath document. And let's remind the viewers at home, what do you win if you're 123rd? Oreos. Win them this year, or they're stale and it's no good. All right. Oh yeah. I'll do this as well. So if you look down in the bottom left corner, right here, right there, it's a subscribe button. Click it right now. Get your Oreos.
I'll mail those.